Welcome back to eCoreAcademy students. My name is Anita and I am one of the teachers and co-founders here along with my younger brother AJ. Today I have a new Algebra 2 lesson prepared for all of you, and as you can see with the title on the screen, it is standard form of a quadratic function. In the last few videos that we've been doing on quadratics, new to this quadratics unit in Algebra 2, we've been mainly focusing on vertex form of a quadratic function. By now, you should be familiar with that and the properties and different problems that will come up, along with how to graph a parabola using vertex form. However, there's another form when we write quadratic functions, and it's called standard form. It's a little bit harder to graph with, so we're going to be running through all the properties of it in this video. As you can see, we're doing part 1 of standard form of a quadratic function. In this video, we will be focusing on introducing you to standard form and then going through the process of using standard form to actually graph a parabola, because it's a little bit more complicated when using standard form instead of vertex form. Finally, we'll do a graphing problem together. Part 2, which will be the next video, is going to be solely focused on practice problems with standard form, and then we'll also incorporate a little bit of vertex form. So that is going to be part 2 that we are going to be planning to make the next video. So let's take a look at different ways of writing quadratic functions using standard form. Before you continue this video, I would really appreciate it if you paused and liked the video to show your support for AJ and me as teachers and co-founders here at eCoreAcademy. Also, subscribe so you can join our expanding student community. Don't feel afraid to drop a comment down below because we love hearing your thoughts. And also, hit the post notification bell so you're notified of our latest posts if you don't routinely check YouTube. Use our socials in the description box below to share our videos and our platform with everybody you know who you think will benefit from this. It will be super helpful. Okay, let's get right into the content I have planned for today for us. So first, we're going to be going over some key concepts. I know whenever we start a new concept in Algebra 2, I really emphasize key concepts because you got to get the notes down and you have to have the foundation before we actually start going through those fun practice problems. So let's go over standard form and the process of graphing it. So first, we're going to go over what standard form is and break it down, like the actual, I don't want to say formula, but the basis of it. Like if you think about vertex form, let me write it here. Vertex form looks something like y equals a times the quantity x minus h, that quantity squared, plus k. So this is what we're going to look at, something similar. We're going to look at something similar to this with standard form. We're going to break that formula, as in that foundation, down so you understand each part of it. And then I'll run you through the 6 steps of graphing a parabola using standard form. Okay, so first slide, we're going to be going over standard form. This equation on the screen, y equals ax squared plus bx plus c. You must have guessed it. This is standard form for you. It depends on the values of a, b, and c. So if you look here, we got y here, which is like our y coordinate. We should be familiar with y and x by now. We got x here, and it's a squared term because remember, when we're working with quadratics, we work with squared terms, and another x here. So the values we're not exactly familiar with are the a, the b, and the c. So the whole process of understanding standard form is a, b, and c change. So what a, b, and c are determine the properties of this quadratic function. Those are the variables that change, and those are the variables that differentiate one quadratic function from another. So I just want to emphasize it depends on the values of a, b, and c. Okay. Let's go to the next slide, which is just a continuation of standard form. We're going to be breaking down what a, b, and c exactly are. So all are constants. Constants are terms in algebra which don't change. So let me give you an example. Let's look at y equals mx plus b, right? That is a normal linear function that you should be familiar with. So we know m is slope and b is your y-intercept. Well, a linear equation, like a complete linear equation, would look something like this. Y equals negative 2x plus 1. I'm just making this off the top of my head. In this case, m and b are constants because they're values that stay the same. So look at this equation I just wrote here. Y y equals negative 2x plus 1. So x and y can change. So I could plug negative 1 in for x. I could plug 500 in for x. Whatever I want to plug in for x, and then y will be determined after following that. However, negative 2 and 1 don't change. They're constants. Think of the word constant itself. Doesn't change. It's undeterring. So those are what A, B, and C are. So A represents the direction the parabola opens in vertical properties. So it's exactly the same as in vertex form. If you remember, in vertex form, A determines exactly this. Does the parabola open upward? Does it open downward? As in, is it reflected across the x-axis? Is the parabola compressed vertically, or is it stretched vertically? Let's review that real quick. I'm just going to box this in so we know A. So what do we mean by the direction the parabola opens? Well, does it open this way, meaning that A is positive? Or does it open this way, meaning the parabola is reflected across the x-axis and A is negative, which is A is just less than 0. So that's what this direction the parabola opens means. And vertical properties, what does this mean? Well, if A is somewhere between negative 1 and 0, as in is it a integer or is it like a decimal? So if the value is something like 1/2, 0.75, if it's less than 1, it can either be the negatives, negative 1/2. If it's less than 1, or if it's greater than negative 1, as in it's a decimal, well, then the parabola is going to be vertically compressed. What does this mean? For lack of a better words, I want to say it looks fat, which means it'll look something like that. It'll look more stretched out. The opposite is also true. So if value of A is like 5 or 500 or 7.25, if it's a larger value like that, greater than 1, well, then your parabola is going to look more compressed. So it's going to look skinnier. This, if you look at it vertically, this graph over here, it's vertically compressed because it's like squat. It's compressed. Compressed means squished. So that's why we say vertical compression for that. This graph over here is vertically stretched. So it's almost like we're pulling it vertically. So that's what A determines. Those are the two things A determines. And let me just underline vertical here. Okay, next let's look at B. So B really, I don't want to say it's like if you think about like the middle child, a lot of people say that the middle child is like the unimportant child. B is obviously fundamental. You have to have B to have the whole quadratic function when you're doing standard form. However, B is just the middle number. I really don't have any other properties to give you. Just know it's what comes after A. So y equals ax squared plus bx. Bx is like that middle term. So that's all you really need to know about B. And lastly, C is pretty important. C is the y-intercept. So let me just write standard form out for you down here. So standard form is y equals ax squared plus bx plus c. If you see, C doesn't have any x term. It's all by itself. So C is the y-intercept. If you don't remember what y-intercept is, it's where the function touches the y-axis. It's when x equals 0. So let me just draw like a mock coordinate grid here for you. So you're probably familiar with y-intercept when working with linear equations. Well, if I have a parabola that looks something like this, where is the y-intercept? The y-intercept is right here, where I just drew that really obnoxiously big circle. That is your y-intercept, and that would be your C value. That's when x equals 0, y equals some value. And that some value will be your C when writing it in standard form. So that's all you need to know about A, B, and C, which are all constants in standard form. Next, let's look at some graphing properties. How do we graph with standard form as opposed to vertex form, which, like I told you before, it's a little bit easier to graph with vertex form. So the most important point to identify when graphing the parabola is the vertex. Let me just underline some key points. So the most important point to identify when graphing the parabolas is the vertex. So if you remember, the vertex is the middle point of a parabola. Let me just draw a parabola up here if you don't remember. vertex is this point right here. It's that middle point. If your parabola is, I want to say a normal parabola that goes upward like this, meaning your A is positive, your vertex will be your minimum. And if your parabola is reflected across the x-axis, meaning your A is negative, then your parabola is going to be up here and it's going to be a maximum. So the right-hand scenario is maximum, left-hand scenario is minimum. Your vertex is going to divide your parabola perfectly into two symmetrical halves. Remember, your axis of symmetry is going to run right through your vertex. So that's what a vertex is, just a refresher in case you forgot it. So why is it important? It indicates the center of the graph. So it indicates right the smack middle of where your parabola is. And that's so important because it's almost like we found the middle, we found the foundation, now let's build around it. Now let's find the other coordinates so we can actually sketch a graph of a parabola. So that's why it's important, because your vertex indicates the center of the graph. Also, it's used in most applications of the quadratic function. So applications are like problems and things like that. The word vertex is just going to be coming up in your head, coming up in the problem over and over again, because it's such a fundamental part of graphing your parabola. So that's why I just wanted to make clear to many of you, because you might be thinking, why is the vertex important? Well, these are two reasons why it's very important, especially in standard form. Your vertex will save you when trying to graph these parabolas. Okay, let's go to the next slide. So we're going to be starting our steps of how to graph a quadratic function in standard form. We're going to be going through 6 steps on how to do this. So here's graphing. I've written standard form on each of these slides. Just like vertex form, you got to drill it in your head. You've got to memorize this. Y equals ax squared plus bx plus c. Pretty simple. I know you're capable of doing it. You probably have it memorized by now, but just in case, I have it written on the top of every slide. So step number 1, identify the opening. So what does this mean? If A is greater than 0, opens up. If A is less than 0, opens down. So what does identify the opening? So does the parabola open upward or does it open downward? So if A is greater than 0, A can be a value, I'm just going to make up a value. A could be like 10. And then your parabola would look something like this, opening upward, and then your vertex is just down here. So make sure when you're given I'm just going to make up a quadratic function in standard form. Let's say y equals, let's just use that 10x squared. I'm just going to make up a b term plus 5x plus 4, something like that. First, you want to look at this 10 right here, which is your A term. This is going to be the first thing you're going to be doing. Identify the opening. Well, does this parabola open upward, meaning A is positive, or is it going to open downward, meaning A is negative? Well, in this case, it's going to open upward because 10 is a positive number. If A is less than 0, meaning A is a value like negative 10, then our parabola opens downward because it's reflected across the x-axis. Your vertex is going to be up here. So first, you want to identify which way the parabola opens. Does it open upward or does it open downward? Simply do that by finding out if A is greater than 0 or less than 0. Okay, hopefully that first step was pretty straightforward. Again, standard form, just in case you forget it. Second, find the axis of symmetry. So how exactly are you going to do that? Well, remember, the axis of symmetry, I just want to write here, axis of symmetry is equal to, I'm sorry, I'm so slow at writing. Axis of symmetry is equal to h, and what is h? Well, it's the x-coordinate of your vertex. Remember hk? These are the coordinates of your vertex. Well, h is your x-coordinate and k is your y-coordinate. Well, your axis of symmetry is x equals blah, 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 which is your x-coordinate. So essentially, you're finding your x-coordinate of your vertex first. And let's look at exactly how to do that using standard form. So you're going to be finding the x value of the vertex, as I just said, h, which is the axis of symmetry. Remember, we abbreviate axis of symmetry as AOS. So x value of vertex is h, which is, and then it's just exactly what I just set up here. X equals negative b divided by 2a. This is something you also need to memorize with standard form. So what does this mean? the x value, so if you look at standard form, y equals ax squared plus bx plus c, you can't just directly derive the vertex from there. If you looked at vertex form, you would see the h and the k, and you'd be able to pull a vertex from there. However, you got to manipulate this, meaning if I give you an example, you'll be able to understand. So if we're working with the standard form, I'm going to use a similar one that I did on the last slide, y equals 10x squared plus 5x plus 4. We can't pull a vertex from this. That's why you need to apply this equation, this principle I gave you, x equals negative b over 2a. So what does this mean? You take your b value, which is 5, and you make it negative. So if it's positive, you make it negative. If it's negative, you make it positive. In this case, our b value is 5, so 5 times negative 1 is negative 5. So x is equal to negative 5 over, 2 times the quantity of a. So what is a in this equation here? A is 10. So 2 times 10. So that's what the b and a mean. And then we just continue, negative 5 over what's 2 times 10? 20. And then we get negative 1/4. And this is our x. This is the x value of the vertex. So you already found what h is, what h of the hk coordinates are. You've also found the axis of symmetry. So the axis of symmetry is so the axis of symmetry in this case would be x equals negative 1/4. And again, you've already found the x value of the vertex. So that's going to be your second step, finding the axis of symmetry, also h, which is the x value of the vertex. Let's move on to the next slide. So graphing standard form again I've written for you. Third is finding the complete vertex. You've already found x. Now what do you have to do? You have to find y. So again, I just wrote this up here, x equals negative b over 2a. To find h, which is the x value in the coordinates of the vertex, you have to apply this. So you just take your standard form, and then you take the b value, you multiply it times negative 1, then you divide that by the quantity of 2 times whatever your a value is, and you should be able to get it. Just memorize x equals negative b over 2a. Just memorize that. Next, you might be wondering, how do I find the y value? Well, if you're trying to reason, you might have already guessed this. Well, y is going to be f of negative b over 2a. So what does this mean? So I'm just going to use the previous example of y equals 10x squared plus 5x plus 4. Ooh, I hope this doesn't get messy. Okay, and I'm just going to use the same example, and what did we say? We said x is equal to negative 1/4. Using vertex, we use negative b over 2a, and we found this because we took negative 5 divided by 2 times 10, which is negative 5 over 20, which is negative 1/4. So we found out what x is now. So how do we find out what y is? So y equals f of negative b over 2a. What does that mean? Well, we're taking the value of x, which is negative 1/4, and we're going to be plugging it back into y equals 10x squared plus 5x plus 4, and that's going to give us the value of y. If you don't see this, let's actually work through this together, and hopefully this doesn't get too messy, okay, because I'm working with a fraction. So y equals 10 times the value of negative 1/4, because we're substituting negative 1/4 in for x to find out what y is, squared plus 5 times negative 1/4 plus 4. Then we are going to just simplify this. Y equals 10 times negative 1/4 times negative 1/4 is 1 over 16. Plus, not plus, so 5 times negative 1/4 is negative 5 over 4 plus 4. And then you would just continue onwards, and then you would solve for y, because now you just have a bunch of constant values. So you just do 10 times 1/16, and then you subtract 5/4 from that, and then you add 4 from that, and you should find the y value. I'm not going to go through the whole thing, but hopefully you understand. You plug back in the x value of the vertex, which you found by using negative b over 2a, into your standard form, and then you'll figure out what your y value is, because you've already plugged a value, you've substituted a value in for x. So that is how you find the complete vertex. And remember, vertex is hk. Do not forget that. Okay, next slide. Step 4. Again, standard form on the screen for those of you still trying to memorize it. So next you're going to find the y-intercept. Remember, the y-intercept is your value y. So y equals x squared plus bx plus c. So this is going to be the value we're finding now. And we're going to be writing it as 0c, because remember, x has to equal 0, so you can find the y-intercept, and whatever the y-intercept is c. So I just wrote it as 0c. That's the coordinate. So how do we do this? Plot it, then plot its reflected point. So what does this mean? Let's use the previous example. So y equals, I know I keep using this example, but it's like the first one that came to my head, plus 5x plus 4. So if we look at this right here that I've given you, 0c, do you remember how when we had the vertex, when we had the x value of the vertex, negative 1/4, we plugged it into the equation and we found the y value of the vertex? Well, we can find what the y-intercept, what the y value of the y-intercept is, because we already know the x value of the y-intercept is 0. X has to be 0. So let's plug 0 in here. If you already don't know that 4, if you didn't know that 4 was the y-intercept, that's why you would do this. But either way is fine, just in case you didn't see it. So y equals 10 times the value of 0 squared. Remember, because we're plugging 0 in for x, because 0 is the x value at the y-intercept, plus 5 times 0 plus 4. Well, if we simplify this, 0 squared is 0. So this is pretty much just 10, sorry, my pen glitched out. 10 times 0. What's 5 times 0? That's just 0 plus 4. And then you get 10 times 0, which is just 0 plus 0 plus 4. And then your y-intercept, you find out, is 4, which we already knew, because we already know that the y value is the c value is 4, which makes it the y-intercept. So in case you didn't see that immediately, you would just go through this and you would do this and you would figure it out. Then what does it mean? Then what you would do is, you've already plotted your vertex on the graph, then you would plot the y-intercept wherever it is relative to the vertex. What you would do then is you would plot its reflected point. So you can pretty much gauge it by a mirror image. So if this was our here, let me draw it here. If this was the coordinate plane, like this, and our vertex was exactly at 0, 0, let's just say that, and oh wait, never mind, forget that, pretend the vertex is not at 0, 0. Let's say the vertex is over here somewhere, and our y-intercept is over here that we just found by doing this. What it means by plotting its reflected point is you would just plot a point, you would plot the exact point over there. So you would plot a point in this case, because the y-intercept is 0, 4. You'd plot another point that falls on this graph that also has a y value of 4. So you just reflect it, and you can usually do that just by looking at the graph, and you can just reflect it. So that's what it means by reflected point, because when you're graphing an equation, you're trying to get as many easy points as possible plotted, so you can sketch the most accurate graph of a parabola. Okay, let's look at graphing. Standard form is written again, step 5. So we're almost there. You're going to be finding one more point and plot it along with its reflected point. So at this point, you can just pick an x value, plug it into your quadratic standard form, and find the y value and just plot it. I would just pick an x value that's very small, that's very close to the graph you have so far, and then you would just plug it into your standard form, find the y value, and then just reflect it as we just did with the y-intercept. So that would be the easiest way to get a good 5 points, including your vertex, then your y-intercept and its reflected point, and then another point, and then its reflected point. Usually when I was in math class, my teacher asked always to graph 5 points. She said you must have 5 points before you can sketch a graph if you want full credit on the problem. So I always stick to that standard of 5 points. And then you just sketch the curve. So what does sketch the curve mean? Well, if I have my coordinate plane like this, my x-axis here, and then I say my vertex is like over here, and then my y-intercept is right here, and then I reflected it and I got the exact amount that it would, the correct reflected point, and then I found another point somewhere up here, and then another point up here. And what sketch the curve means, I just draw a line through these points to indicate the parabola, because you can't just leave points on a grid. You need to sketch the parabola and indicate parabolic function. So that's what sketch the curve means. So those are the six steps to graphing a quadratic function. Okay, next section, practice problem. I'm super pumped for this. Let's do it. So the practice problem. Let's do one problem on graphing using a quadratic function in standard form. I'm going to show you how we're going to work through this together. Okay, so here's the practice problem. Again, I write standard form on this. I think this is the last slide, but you should know it by now. So standard form is written up here for you. Y equals ax squared plus bx plus c. That's what we're going to be using. Here is the problem. Use the previous process, as in the graphing process I just showed you, the 6-step graphing process, to sketch the following. So what you want to do is you want to find your 5 points and then sketch a graph, sketch the curve through them, and then you want to label the vertex, and then you want to label the axis of symmetry, of course, after finding what they are. So you're going to be using the quadratic function in standard form, y equals x squared minus 6x plus 9. So this is what you're going to be finding the 5 points and plotting, and then you're going to be sketching the curve. Then you're going to be finding and labeling the vertex and axis of symmetry for this quadratic function. Let's do it. So I just wrote the problem at the top of the screen so that from now on, I'm going to do this so you can refer back to the problem while we're doing the solution. So use the previous process to sketch the following, then label the vertex and axis of symmetry, y equals x squared minus 6x plus 9. So here's the solution I've already pre-written for you in case you want to just listen on the next slide when I actually walk you through it. If you want to copy it down, feel free to pause the video and do that, and then you can just go through it with me, or just go ahead if you just want to see me walk through the problem with you. So I'll give you 1 second if you want to do that. It's just more neatly written out here if you want to look at it this way. Okay, let's continue on to the next slide where we are going to be doing this practice problem together. Okay, so we're going to be walking through this practice problem together. So again, the problem is written at the top of the chalkboard. If you want to refer back to it, we're going to be solving the problem together. Here's a graph just for me so that I have one to show you this problem on. So I'm just going to rewrite the equation up here. It just helps to rewrite it because then you just remember what you're working with. At least that's what I like to do. So this is the equation, y equals x squared minus 6x plus 9. So we're going to be solving this. So what are we going to be doing first? Well, we're going to be identifying, does this graph open upward or downward? Look at the a value. It's just x squared at the beginning. So you're going to assume the a value is 1 because we don't write 1 in front of x. Well, is 1 positive or negative? Well, 1 is positive, so this graph is going to open upward like this. Your vertex is going to be a minimum, and it's just going to be like an average graph. It's not going to be reflected across the x-axis or anything like that. Next, let's find our axis of symmetry, which is h, which is the x coordinate of the vertex. So how are we going to do that? Remember negative b over 2a? That is what we're going to be applying here. So I'm going to write underneath this, x equals negative b over 2a. And what is negative b in this case? So I'm just going to write the negative sign. B in this case is negative 6. So negative times negative 6, because remember negative b. And then over 2a. So what is a in this case? Like I said, 1. And then we're just going to be simplifying this. Negative times negative is positive, so this becomes 6. And 2 times 1 is 2. So we find out that our axis of symmetry and our h value of the hk, which is our x coordinate of the vertex, is 3. So we already have that solved. Now let's find the complete vertex. So how are we going to do that? We have to find the y value. So we're going to plug this x value back into this quadratic equation up here, find the y value, and then we're going to have the complete vertex like set. Okay, so let's do that. So y is equal to, I'm just going to write an arrow here. Y is equal to, we're going to plug 3 in for x. So 3 squared minus 6 times 3 plus 9. Then we're just going to really just simplify this. So 3 squared is 9. 6 times 3 is 18. So this would be minus 18 plus 9. And what is that? Well, 9 minus 18 is negative 9 plus 9. Well, that's going to be exactly 0. So from this, we can derive that our vertex is equal to 3, 0. So now we know the vertex. I'm just going to box this in. So our vertex is 3, 0, and we just found that by doing the 2 previous steps. Okay, so I'm just going to skip ahead a little bit. We know that our y-intercept is 9, but because this graph is small, we are not going to do that. I'm going to show you a different way to do it, much easier. So we know our y-intercept is 0, 9, because if we look up here, the c-value is 9. And as we know, the c-value is our y-intercept. Now let's just go right into actually plotting the points. So first let's plot the point of the vertex, which is 3, 0. So come over here, 3, and then plot it at 0. So right here, so 3 and then 0 here. So right here would be our vertex. So as you remember from your linear equations, whatever your teacher always says, once you find that one fundamental part of your graph, you can just simply make an XY table and then you're good to go. You can find other points and you can sketch the most accurate graph possible. That's exactly what we're going to be doing right now. So we know our vertex is 3, 0. So what I'm going to do, like I said, we want 5 points. I'm asking you for 5 points, your vertex, then 2 points, and then 2 more points. That's going to be your optimal way to solving a problem, especially if you're doing an assessment. So here in the very middle of your graph, you're going to put 3, 0. Skip the first 2 slots and then leave the last 2 slots open. Why are you going to do this? Well, I put 3, 0, which is the vertex, in the middle of this XY table because it's the middle of your parabola. It's the center of your parabola. So what you can easily do is you can pick one x value, 1 point above it and 1 point below it. They'll both share the same y value because they're a reflection of each other. And then you pick 2 x values above it and then 2 x values below it. And then they're a reflection of each other. Let me show you what I mean. So if I pick one x value above 3, that's obviously 2, and then one more is 1. And then if I pick one value below 3, it's 4, and then another is 5. So this is just all centered around that vertex, which is 3, 0. Well, let me just do some mental math. Mental math is really important. There's a reason we learned it in 2nd and 3rd grade, because in these scenarios, you can just easily plug the x values into your original quadratic equation and just mentally come up with the y value. So if I plug 2 into our quadratic equation, 2 squared is 4, minus 6 times 2, which is 12, so 4 minus 12 is negative 8, plus 9 is 1. So I did that all mentally, so I know the y value here is 1. 2 is a reflection of 4, so I can also write 1 for 4 because they're reflected. They share the same y value. They're on that same horizontal line. If you looked at a parabola, it's just a horizontal line, so they share the same y value. Let's do the same for 1 and 5, which are a reflected pair. If I plug, let's plug 1 in. 1 squared is 1, minus 6 times 1, which is 6. So 1 minus 6 is negative 5, plus 9 is 4. So this would be 1, 4, and this would be 5, 4. So we just solved that whole xy table. Now let's go and graph all of these points. So the vertex and the 4 other points. Let's graph these 4 other points, 2, 1, 4, 2, 1, 4, 1, and 5, 4, really quickly. So 2 is right here. I go up 1, 2, 1. Let's do the same for 4. 4 over, 1 up. And then let's do the same for 1. 1 over, 4 up. And then lastly, 5, 4, 5 over, 4 up. So you can actually see the parabola start to shape up, which is really cool. So now let's sketch the curve through these points. So I'm just sketching this curve. Sorry if it's not perfect or anything, but this is what the curve would look like for the parabola. Now you can see the parabola. There's one last important thing we have left. We have to label the vertex and axis of symmetry. So let's do the vertex first. So let's just say vertex, I'm just writing it down here on the graph. Vertex is equal to 3, 0. And where's the vertex? Well, I'm just going to draw an arrow right to the vertex. That's what labeling is. Then the axis of symmetry, I'm just going to abbreviate it AOS, and in parentheses, I'm going to write what it is. It's x equals 0. Well, how do I label the axis of symmetry? So whenever you draw a parabola, you got to actually draw the axis of symmetry as well. And this is how I personally do it, and this is what worked. I get full credit on problems for doing this. I just make, you see how the axis of, I wrote axis of symmetry equals 0. That is not correct. It is 3. So let me just change that to 3. X equals 3. So you see this vertical line x equals 3 right here. My pen is going over it. I'm just going to dash it like this. I'm just dashing it like that to indicate this is the axis of symmetry. That's what I do, and that's what I suggest you do. And then you just draw a line indicating that. So that's how you denote the axis of symmetry. And this problem is all finished. Kudos to you if you were able to stick through that. If you couldn't, just replay it and you'll get it, trust me. Okay, so that's all I have for you today. I hope you enjoyed that lesson. Again, a quick recap. We went over what standard form is, then we broke down the 6 steps to graphing a quadratic function that you receive in standard form. Then we did a practice problem together. Hopefully that was helpful. If it was helpful, please like the video to support AJ and me as teachers and co-founders here on eCoreAcademy. Also subscribe to join our student community. Hit the post notification bell to get notified of our latest posts, and don't feel afraid to drop your comments down below. Lastly, use our socials like Facebook, Twitter, and Instagram, and use them to share our videos and news about our platform on them with all your friends and family. It would be very helpful because we just want to help as many students as possible during the pandemic. Our website is going up, which I keep reiterating. It has some sweet functionalities on it that are obviously not accessible if you're a user on the channel. If you're a student on the website and signed in, you can access our notes and quizzes and all these other cool things. So please look into that. And lastly, if you have any personal or business correspondences, please reach out to our Gmail, eCoreAcademy@gmail.com. That's all I have for you today. Please have a wonderful day, and I'll see you with part 2. Bye.